Hello, everybody out there. Welcome to Amateur Radio Roundtable. Today is Tuesday, July the 14th, 2015. I'm Tom Medlin W5KUB, and I'm with our co-host tonight, Ted Randall WB8PUM. And we thank everyone for joining us tonight. Ted, how you doing tonight?
Oh, doing pretty good, Tom. So, what's on the agenda for tonight? Tell the folks what we've got coming up.
Well, we're going to talk about Amsat tonight, and we've got the main guys here that should be able to fill us in on everything you always wanted to know about Amsat. So, last week we showed everybody how to work some easy satellites. Tonight with us, we've got the Vice President of Amsat Engineering, Jerry Buxton, N0JY. And we also have the Vice President of Operations, Drew KO4MA. And Jerry and Drew are going to talk about a lot of the latest things happening with Amsat. We're going to talk a little about Fox 1, I guess Fox 1, is it C or A? I don't know. Operational satellites. We're going to talk about and some future opportunities they've got there. So let me... First, let me make an announcement. If you have any questions during the show tonight, please instant message Kathy. If you will, just click on Kathy's name, click instant message, and then type your message, and then she'll be able to read all these questions back to us in a little while. Also, Ted probably will open up the call-in telephone lines later, so we might can bring some voice calls in. So just send Kathy your questions, and we'll get to them. Well, I'd like to say, Drew and Jerry, thanks so much for coming to the show tonight and sharing with us and with our audience. How you guys doing tonight? So let's see, we got three people on here. Drew, why don't you go first?
Good evening, everybody. Happy to be here and hope to get everybody informed on what's going on with Amsat now. There's a lot of exciting stuff and launching 2 satellites this year, and just want to get the word out there.
Okay, and we need to tell our audience that you're at a hotel right now, somewhere, I guess down in Florida, and we think that's the shower running in the room next to it. All right, so where are you, Drew?
Working the PTT button here.
Yeah.
I'm not an engineer, but I did stay in a Holiday Inn Express last night.
Okay. So that ought to work out really well for you there. I know it's going to be a good show now if you stayed there last night. Perfect. And let's go to down to Texas and say hello to Jerry down here. Hey, Jerry, how you doing?
Hello, Tom, everyone. Doing really good, thank you. It was 109 degrees heat index this afternoon here, so inside's a good place to be.
Well, it was probably near 100 here today, and we had 14 severe storm warnings tonight, and 70-mile-an-hour winds came through here about 5:30. We lost power once, but it came back on, so hopefully we got our fingers crossed, and we're going to be on tonight. Hey, before we jump right into you guys, I just want to mention one thing. We're kind of talking about space tonight and so forth, and one of the things I wanted to tell our audience out there, let me see if I can pull something up for them there. But for our audience out there, we're making history tonight. About 5 minutes before the webcast started tonight, the New Horizons Pluto flyby was going on. And at about 5 minutes until 8 tonight, they had it set up, and it was a agenda, and it was called Phone Home, I guess, like ET Phone Home, and the vehicle was going to start sending back to the U.S. again and giving us more pictures. One of the things about this project, this vehicle's been heading to Pluto for the last 10 years. Almost 10 years it's taken to get there, and it's passed within, I think, 15,000 kilometers of the planet. And it takes 4.5 hours for the radio signal to come back one way. That is a long time. So they hope it's not dead. So Phone Home was turned on tonight, right before the broadcast, and it's supposed to let us know if it's still alive out there. And this planet, our dwarf planet Pluto, orbits the sun every 248 Earth years. It takes 248 years to go around the Earth. So if you guys would Google New Horizons, you'll see that. So history is being made, and also history is being made with a webcast. I think this is the beginning of our 6-month mark on our webcast. We've been lucky that we've been able to keep the schedule for the last 6 months, and I hope we can continue for 6 more months. So let's jump back to our Amsat guys now, and we're going to get started.
Let me ask
ahead.
a question. Hasn't Pluto been downgraded though? I mean, didn't we lose Pluto as a planet? Now they consider it something else.
Yeah, Pluto was downgraded to I think they call it a dwarf planet, and it really made some of us a little unhappy.
I was going to say, I guess it lost some of its political capital.
Well, yeah, it surely did. And you know what? Now I got to go back to school and start all over because it's not a planet anymore.
I'm sorry I interrupted, but I just
no, that's
when
okay.
you were talking about Pluto, it just passed by my head. I thought, well, they've downgraded it. It's lost all of its political capital now. So that is Amsat.
That is true. That's true. All right, let's jump back over to Drew there. And Drew, tell us just real briefly when you got your ham ticket and how you got involved in satellites and how you got involved with Amsat.
Sure. I got my ham license when I was 13, back in the late 80s, and one of the earliest. I played on 10 meters in HF for a while, but when I went to college, I ran into some hams in Jacksonville that were involved in satellites. One of them happens to be the president of Amsat now, Barry Baines, WD4ASW, lived down the street from me. And I used to log into his AO16 packet gateway, where he bridged from satellite packet to terrestrial packet. And myself and a good friend of mine, Paul, KV4PML, started listening to Dove, Oscar 17, that had a digitalker on it. And we started using our 1200 baud terrestrial packet stations to collect telemetry from Dove, and plotted it in Microsoft Excel, and just went full on geek mode with it. It was great. And from there, I was active on RS-12 primarily, and that was a mode K transponder. So we went up on 15 meters and came down on 10 meters. I had lots of fun with that, and sort of drifted away from ham radio for a little while, and came back to it in the late 90s, 98, 99, and got on SO35 and UO14, and back on RS-12, and just kind of went into a free fall with it there, and have tried to work every satellite that they put up, and now have been working with Amsat for I guess about 10 years now, and got the chance to be the command station for AO51 for the second half of its lifetime, and just really have had a great experience with satellites and ham radio all the way around.
Well, that's great. Let's jump to Jerry. Jerry, same questions for you. How did you get started in ham radio, and how did you get mixed up with this organization?
Well, I got started in 1972. I was 16 years old, and that's when I got my novice license. I held that for a couple of years, then got my general. It wasn't until 76 is the oldest log record I can find. I've lost my log records prior to that. They may be in my mom's attic or something, but that was some of my first satellite contacts using AO6 and AO7. So I became very interested in that. I think it's a product partially of being, born 1 year before Sputnik flew. So the space race was a big part of your life then. And that hooked me. I mean, working the satellites was fun because there was a lot to it. It wasn't simply, quite as simply working the radio. There was calculations you had to do, which back then were most interesting as far as trying to determine when the satellite would be in range and stuff. There were quite a few little aids that were there way before computers, of course, or personal computers. And that stayed with me throughout my life. In 1993, I moved to Illinois and got my first house, and the immediate thing I did was put a couple of a 40-element KLM and a 20-element Cushcraft circularly polarized antennas on top with the Yaesu rotator, and got on Oscar 10 and Oscar 13. Those were a lot of fun. And I really had fun working the satellites, especially, you know, it was fun to come back in the old days, so to speak, when it took 4 hands to do it because you had to do the logging, tuning, antenna rotating, and key the microphone all at once. And I remember once I had a really long path contact through AO13 with a guy who lived 45 miles away when AO13 was at Apogee. So it was quite an interesting way to work somebody I could have worked on 2-meter simplex. 1996, I moved to Texas with the railroad. In 2011, after being a longtime supporter of Amsat, I decided, you know, I wish there was something else I could do to help give back. And I contacted Tony Montero, our then vice president of engineering, and asked if I could help with anything with Fox One. He gave me a pretty good interview about what I know and what I do. Coming from the railroad, I don't have the aerospace background, but I have a lot of project management and design experience, and really the systems that we work with on the railroad are very similar to what we do with the aerospace. So he said, okay, you're hired, you can be the systems engineer. So I started working on the Fox project. And in March of 2014, unfortunately, when Tony passed away, then Barry tapped me to ask me if I'd be the vice president of engineering, and not wanting to see the Fox project go down the toilet because Tony had passed away, I immediately asked Sarah if that was okay with her, and I got the job. So here I am. It's been a lot of fun since then. Giving back is what I've been doing. We got Fox One out the door, and it's been a lot of fun.
So did you ever think when you were a kid, 16 years old, getting your ham license, that someday you would be a VP of Amsat?
No, that's something I do think about, though. It's like I told Sarah it's a job of a lifetime. I mean, it's not a paying job or anything, but it's certainly, how often do you kind of just fall into something like that, so to speak? So heck yeah, it's quite a bit of work, but it's definitely a lot of fun.
All right, well let's go back to Drew. And Drew, you want to tell us a little about maybe the history of Amsat and where you came from or where you're going there? Go ahead and let's talk a little about that.
Sure. Well, it all started with Oscar 1 and Project Oscar in California, and that was put together by a small group, Lance Skinner and some of his friends and associates. And after I think the first 4, when Oscar 5 came around and was, it was long before I was born. So Amsat was formed to pick up from where Project Oscar left off. And they started, there was an Australian satellite that was refurbished and launched that became Oscar 5. And then beginning with Oscar 6, the Amsat started building the transponders and handling it under Amsat. And Oscar 6 was launched, and the follow-on Oscar 7 was launched in '74, a month after I was born. And amazingly enough, Oscar 7, after taking a 20-something year nap, is working right now, and it's our highest orbit satellite right at the moment. The battery shorted out sometime in I think it was 83, if I remember what I read correctly. And about 10 years ago, they opened back up the short, unshorted, and now the satellite runs off of the solar panels, and it is it's illuminated most of its orbit, so it's there. There's no computer to reboot on it. So when it comes out of eclipse and comes into orbit, it powers up, and we have a transponder running. So the second satellite that Amsat built is still running 40 years later. And there's been a lot of accomplishments after that. Amsat and Amsat DL, and lots of other Amsat organizations around the planet. We've built phase 3A, which unfortunately was lost in a launch accident. The replacement, which became AO10, a high orbit satellite that was covered a whole hemisphere at once. AO13, Oscar 40, which is the largest satellite amateurs have ever built. And despite having some issues, it provided a transponder for over 3 years. So Amsat's done some pretty incredible things.
Well, you were talking about, like, was it AO7 that came back?
Yeah, AO7
yeah.
launched in '74 and
yeah.
and came back in, I think, 2003.
Yeah, I remember when the batteries opened up and then they started letting the solar cells work again, and it had power, I guess, when it was in the sunlight. So that was kind of neat in the fact that it was not computerized. I guess you have a lot to gain with new computers now, but back then, I guess, you didn't put a computer in a satellite. In fact, I think Oscar 7 was launched in '61. That may have been a little early for computers. And, you mentioned slide rules. Let me show you. I mean, I'll show you how old I am. This is my computer. This is my computer in college right here. And if you've ever used one of these, you have to have baby powder. And Drew, you guys probably know what I'm talking about, but you actually use baby powder and you carry it around with you. So this was my calculator back a number of years ago. So now everything is more computerized. I mean, these things do a lot up here.
Well, the computer plays an important part. It controls, gives you your telemetry. It allows you to command the spacecraft. It allows you to do things like schedule. On AO51, the computer on board that allowed me to program scheduled mode changes. We could upload pictures to the bulletin board, download it on the other side of the planet, collect telemetry around the complete orbit to see just what the satellite was doing at any given time. So Oscar 7 did not have a computer on it. So when it came back to life, it was kind of funny. At the time, UO14 was an FM repeater satellite at the end of its life, and its uplink was 145.975. Well, the 2-meter CW beacon on AO7 is 145.972. And for several weeks, we were hearing a CW signal occasionally. And on FM, it was just kind of a thumping, bump, bump, bump in the background. And it wasn't long after that Pat Gowan in the UK figured it out. He just ran across the signal and posted a message to the bulletin board, said, "Hey, what satellite was the one that sent this?" And then we discovered that it was back to life.
Yeah, I'm showing a program right now in the background here, Orbitron, for people that are getting interested in ham radio. Now, you guys, I was looking on the Amsat web page, and you guys have got some tools to use there too, right? Satellite tracking and all that.
We sure do. If you go to the Amsat web page, and up one of the in the toolbar up on the top.
Is this it right here?
That's it.
Yeah.
There's one of them in there, past predictions, I think it says.
Yeah, that's what this is, a past prediction.
Yeah. And you go to that and you just put in your location and pick the satellite you want.
Yep.
And it'll tell you right when it's going to be overhead and however many passes you want.
All right, that's pretty neat. I used that a lot when I was working some satellites. And then you guys had some other tools out there too. I think here's one here of, this is the, status page, I think.
Yeah, this is the David Carr's Oscar satellite status page. This lets you go and either make a report as to what satellite is it operational? Did you hear the transponder? Did you hear the ISS crew? Did you hear the ISS packet? Did you hear the telemetry? And then it spreads it out over, I think it's 5 or 6 days on there. And it's a quick way to check and see what satellite's working. And actually, we're working right now on migrating that over to the Amsat webpage. We've got some code written and we're testing it right now. That's actually hosted on a private individual page, but it may be over on the Amsat site soon.
Okay, a question came in on the chat room. What's the status of AO27? I haven't been keeping up with this lately. Is there something going on with 27?
Well, AO27 is a FM repeater satellite. It's a very popular satellite, and it hasn't worked in over a year. It is was a project of AMRAD in Virginia. It's not technically an AMSAT satellite, so they have their own command stations. They've had some issues, and they had to rewrite some code for it. Their website's ao27.org, and I think there was a message put up there about a week ago that they had uploaded the new code and were going to be in the process of testing it. So maybe if we get lucky, we'll get AO27 back, which would be nice to have an additional FM satellite until we can get Fox 1A and Fox 1C launched.
Okay, and when's that supposed to happen?
Well, Jerry, you want to talk about the 1A and 1C launch dates?
Fox 1A, also known as Fox 1 publicly, currently scheduled for late September. This is riding on an NRO launch vehicle, and therefore the launch, what they're launching is classified. So the information that we're given or that we can share is not quite as detailed as what can happen through, say, spaceflight, who's going to do Fox 1C, as far as making dates and things public. I suspect that the late September is going to stick. I haven't heard anything different about that. There's nothing. It's going to be on an Atlas V, so that the spaceflight Falcon 9 error is not going to affect that. And Fox 1C then is currently scheduled for December 2015, and that is the Falcon 9 launch using the spaceflight Sherpa as the payload dispenser. That, because of what happened with the Falcon 9 at the last launch, right now it's undetermined whether that's going to impact our December launch. So I'm waiting to hear about that to find out officially whether or not that's going to have any impact. And if it did, it would push it back perhaps into January or February of next year.
Okay. Well, what we're going to do, we'll get back with Drew in a few minutes, so he can talk about maybe some future plans and anything that he wanted to cover about the past history. He'll have an opportunity to do that. You're here to talk about the engineering side, the technical side. You've been with AMSAT a short time, but you're heavily involved in the engineering, and I think you've got some pictures or some things you want to show us, right?
Yeah, I thought I'd share some of the history of Fox 1 here, if you will. Since it's been completed and delivered, I have a few pictures that I put together regarding the testing and integration. So I'm going to share my screen here. Let's see if I can get that slideshow to show up for you. Let me know if you see a picture.
Yeah, sure. We see it.
Okay, this first picture is actually what they call a test pod. It's a one-unit pod that we put the satellite in and we bolt it to a piece of metal because it's going to be put through the vibration testing. Vibration testing is required as part of the environmental testing, it's called, because the rocket, we have to make sure that we're going to be able to withstand the forces that we're going to experience riding on the rocket, and also to ensure that nothing's going to come apart and otherwise pose a risk to any of the other CubeSats or the primary payload. So once we had it within that little one-unit cube, we put it on the vibration machine. This was done at Qualtest in Orlando, Florida. And what this is the machine that actually performs the vibration is, for all practical purposes, a giant speaker. And they are able to feed various frequencies and amplitudes into it and have it shake the satellite, or whatever the test article is, at frequencies and amplitudes that are provided by the launch provider that they expect that you will experience on the rocket. And actually, we test a little bit over that, 3 dB over that, in order to ensure that everything holds together. So that was the first test that we went through there. We were there for a week.
Yeah, hey, Jerry, just one thing here. We got listeners out there on shortwave that can't see the pictures, and we're talking about ham radio satellites here. Most people know satellites that we get TV from, telephones from, things like that. And these satellites are as big as a car or larger and weigh, thousands of pounds. Just briefly describe this picture here. I'm looking at this CubeSat. Tell us about how big it is.
The CubeSat, the 1 unit CubeSat, which is the size that the Fox is 10 centimeters cubed, or about 4 inches. So it is more or less the size of a big pencil holder, perhaps, or something like that. It's smaller than a Yaesu rotator controller if you've got one of those. It's amazing how tiny it is and the amount of stuff that's packed into it. I'm trying to think of, Drew, you got any thoughts about something that you could handily compare it to, but I can't really.
Well, it's not much bigger than a softball, to tell you the truth. Except it's square.
It's almost exactly the size of a drink coaster at a restaurant, because when we first started talking about building a CubeSat, we were all sitting at a Chili's near the Amsat lab, and we took 6 of them and taped them together, and it's almost exactly the size of a drink coaster.
All right.
And so it is diminutive compared to the machine that they did the testing with, because it's designed to be able to test articles up to much larger aerospace articles, let's say that. As a matter of fact, we had to have the plate that the CubeSat was bolted to specially designed by them, designed and drilled in order to be able to adapt the small CubeSat test pod to be able to fit onto the plate that is part of their vibration testing equipment. So for the viewers, I've got a real short video that you could see here that shows how violently the CubeSat was shaken. I remember how to play it, right? You might be able to hear the noise of the machine in the background too. You can see that it rattles quite a bit. And
now I see the side. I see the side of it. Kind of looks like some type of membrane or cloth or something. You can see it moving in and out, actually.
Yeah, that is Kapton tape that we put over the side in order to keep any debris from getting inside the test pod there. Right here at the end, you can see it shaking quite a bit. So It was 14 G's in that access, if I recall correctly, about 14 G that it was shaking. Then they take the machine, which is, like I said, essentially a speaker, and they rotate it so that it is pointing up vertically. And we mount it again on there for testing in the Z-axis. So this next photo is a picture of that as they swung it around to do the final testing. We have to test all 3 axes. The Z actually was the one that was submitted to the biggest vibrations, and I think that was close to 24 G. So that little thing was shaken to pieces. And once they finished that, we took it back into their offices and did a thorough inspection of it. The screws that you see in the background on the picture did not come from the satellite. And once we realized that it did actually pass it, we had a big celebration, because at that point in time, we were really, worried about the fact that you're going to shake that as hard as they did.
Oh, yeah.
Nothing came loose whatsoever. The next step was to take it and put it through what's known as the thermal vacuum test. And in that case, you put it and you lower it to a vacuum that's close to space, very high altitude that you can get, and you heat it up to 60 degrees Celsius for a period of 12 hours. This is done in order to, it's 6 hours. This is done in order to bake away any contaminants, including finger oils or dust, and to get any residues from glues or any other type of resins and things that are used inside. The parts that are used are all what you call low outgassing, but putting it through this thermal vacuum ensures that all of anything that's left that might outgas is removed and sucked out through the pump, because these residues, if they were to release in space, have a tendency to want to then coagulate and gather on any cool surface they can find, which might highly likely be our camera lens. So they put it into the vacuum chamber. We enclosed it in a thermal hat, a box, and they added some heater elements around the side of it, lowered the top of the bell jar, and we all had a wonderful conversation for about 6 hours, 6 hours plus, because we had to let it cool down a bit after it was done before we could even take it out. And we did go check it, and everything passed. So our next step then came March 25th at Cal Poly State University in San Luis Obispo, California. I took Fox 1 out there for the integration into the P-Pod. The P-Pod is the Poly-Pico Orbital Deployer, which is named after Cal Poly, who invented it. A P-Pod can hold 3 one-unit CubeSats, and it's essentially a metal rectangular tube with a spring in it so that the CubeSats are pushed down, loaded into it. The lid is closed, and then once it's in orbit and ready to be deployed, the lid is open, the string pushes the CubeSats out.
Now, did they spend a lot of money inventing that P-Pod? Why couldn't they just use the Jack in the Box?
You know, one of the ways we describe how a P-Pod works is the old Pez candy dispensers, where you load candy pills into it, in our case satellites, and pull the head back, and the spring pushes them out. Works just the same way.
Yeah.
Yeah, they could have called it a Pez Pod. So I got a few photos of that. We went through the integration. They have to carefully weigh it. It came out at 1.322 kilograms, and then they check the tolerances because it has to make sure that it fits within the envelope of that P-Pod and will not touch the sides or anything as it deploys, as well as not touching any of the adjacent CubeSats. These are all things that come very, very minute tolerances. As a matter of fact, we wound up being out our tolerance on our receive antenna because when we put it through the vibration, the little fishing line that we had tied to it, around a post, the knot kind of turned a little bit in the vibration, and we were 0.75 millimeters outside the envelope when we went to integrate it into the P-Pod. However, it was fortunate that particular point was what touched the pusher plate, so it didn't invalidate us from flying. But that's how close things are. The next photo shows a picture of the P-Pod. It's got a bunch of big wiring on it that they use to control it for opening the lid and such like that, with Fox 1 sitting outside of it. This is all done in a clean room at Cal Poly. There are several people that are gathered outside, and we are inside in the bunny suits doing this work. And finally, the Fox 1 and its 2 companions, which were Arc 1 and BisonSat, from the University of Alaska and the University in Idaho. I'm afraid I forgot their name. I'm sorry. Those are the 3 that went into this particular P-Pod. And so we were all lined up and ready to be inserted into the P-Pod, and I actually got to insert Fox. As you can see in the photo, that there are 2 Cal Poly people there, one steadying the P-Pod and one's actually helping the spring and the pusher down so that Fox 1 doesn't just drop on it and bounce and what have you. And they do that with the subsequent satellites. We get them all packed in. And once that's done, they close up the P-Pod and we pull the remove before flight pin. They put the walls on to cover the access ports, and it's ready to go off to be integrated one more time with 7 other P-Pods into what's known as an NPS Cool. It's the Naval Postgraduate School CubeSat launcher. And this is a big box, essentially, that holds 8 P-Pods, therefore up to 24 CubeSats, depending on their size, whether they're 1 unit to 3 unit, and has the electronics for it to be wired up so that they can control the deployment of each particular P-Pod once they are ready to release them into orbit. This NPS Cool is then packed up into a big container and shipped down to Vandenberg, which is where it is now, and should be integrated onto the rocket in July. So they'll be mounting that onto the 3rd stage, the Centaur stage of the Atlas V rocket here pretty soon, that NPS Cool, and it will be ready to be flown come late September.
Yeah, I have a question for you there. I know that your CubeSat is spring loaded. It's shot out of the P-Pod when the delivery vehicle gets up there, but I guess these orbits are for a low Earth orbit. What are they, around 500 miles, something like that?
Yeah, typically what we're shooting for is a 650 kilometer average sun synchronous orbit, which puts it into around a 98-degree inclination, which is basically a little bit left of over the North Pole. And in the case of Fox 1A, it's going to be launched into an orbit that's approximately 63 degrees inclination. And it will range between 480 and 740 kilometers, I believe, is the
Okay. And does the rocket that when these things pop out, is that rocket already up there in about that area, or do these things travel a little ways after they're launched with the spring?
The rocket, the launch first delivers the primary to its orbit. So they launch the rocket. It goes to whatever state they need in order to deliver the primary to orbit. Then they will fire some retros, if you will, and bring that stage that has the P-pods on it down to the lower orbit. And once they know that they're clear of the primary and everything's cool, they put it into a barbecue spin, basically, so that it rolls around and starts at command releasing the P-pods out of each of the P-pods in sequence that they ask for. So the door opens. Each CubeSat itself, too, has some tiny little springs at the bottom on the posts so that they push away from each other as well as being pushed out by the pusher plate. So they're way far away from the primary mission, and the primary mission, of course, is what it's all about. So they take care of all that business before they get rid of us.
Yeah, so you'll be hitchhiking a ride maybe on something that's going up into a geosynchronous orbit?
Well, I can't tell you that.
Well, yeah.
I would have to say that based on the orbit that we're getting delivered to, that what they are launching is probably not going into.
Okay, all right.
But I don't know what they're launching. It's all classified. So.
Yeah, I understand. Well, I was thinking more geosynchronous orbits, where we watch TV and things like that. But then you have to also remember, which I forgot, you got all these military satellites up there that they fly around up there. They can move them around, and they're not in geosynchronous orbit. So, okay, well, that's some good information there. Now you mentioned Fox 1A, and I thought we were also going to be talking about Fox 1C. What's the difference here?
Okay, well, when we started the Fox program, it is. And was decided that it would be cheaper to build 4 than to build the 1, essentially, because once you've invested the money and the research and development into building the 1 satellite, you can build others at a substantially reduced cost. So Fox 1A was the first one envisioned, and it was in 2012, I believe, it applied for an Alana launch opportunity. It was granted. Fox 1B, as we call it internally, but it's known as RADFXSat, was a project put forth by Vanderbilt University. And Tony worked with them, in which we would take a Fox 1 CubeSat, and they were going to build a special radiation measuring experiment that would go on board that. They applied for an Alana, a CFLI CubeSat launch initiative, and got an Alana launch for that, which we're looking at hopefully happening in November of 2016. We've been put on a list for that particular launch, but who is chosen, it depends on the ranking that you came out of that selection when they made the Alana selection. So Fox 1B, while it's the second one that was designed, will not be produced until later this year and next year. Fox 1C, the opportunity came up then last year, and Drew's the one who found it, where we could get a launch with spaceflight on their Sherpa. And so we bought that launch for Fox 1C. We built Fox 1C using some of the flight spare parts from Fox 1A, and we'll fly the spare Vanderbilt radiation experiment that was flown on, that went on the flight of Fox 1A as well, and we're adding the Virginia Tech camera, which did not make it on Fox 1A. We're also going to add, because we had some extra time to do this, an L-band receiver so that we'll have the opportunity to operate L-band uplink and VHF downlink because we had an empty experiment slot there. So we'll fly that on Fox 1C and D. So I kind of got away on that one, but the point is that when we order circuit boards, for example, you can get 3 PCBs for $1,000, or you can get 8 PCBs for $1,200. We get 8 of them, then we have lots of spares, and that's what reduces the cost of building Fox 1B, C, D, even E, because we have that and the components, cheaper by the dozen, if you will. So we can get many satellites built for just a little bit over the cost of what it costs for one.
Okay, and just another question. Are you guys planning anything high or up toward a geosynchronous orbit?
Yeah. When you mentioned the geo, we have an opportunity before us to fly a hosted payload on a geosynchronous satellite that is designed and built by Millennium Space Systems, that is a government U.S. Air Force satellite that they're going to launch. And one of our AMSAT members, Bob McGuire, found the opportunity that we could have to fly a payload on that. So we're working right now on developing a payload that'll use 5 gigahertz uplink, 10 gigahertz downlink, and will provide an opportunity at those frequencies. You've got 10 megahertz of bandwidth or even better, for many types of communications, from analog to digital, and with a focus on emergency communications, because this being positioned over I call it Region 2, but the Western Hemisphere, United States, Latin America, Central America, South America, Canada, gives an opportunity for the design we're looking for to be able to take small portable equipment out to the field and provide emergency communications in a reliable manner through a satellite that's there 24/7. So that's a very exciting opportunity that we're working toward. The launch is to be in late 2016, and so there's a lot of hustle that goes along with that. But that
Okay.
just kind of came to us, just dropped in our laps, if you will, I guess. And Bob said, "Are you guys interested in helping build this?" And Virginia Tech is going to be the lead on it. They're the ones that are doing the contract work for it. AMSAT's providing volunteers, and AMSAT will operate the satellite because it needs to be operated by an amateur radio organization. And Drew, you got anything you wanted to add to
that? It's going to be exciting to have hemisphere-wide coverage that you can access with probably a 1 meter dish or so, or 2 1 meter dishes for the uplink and the downlink. This is real similar to what AMSAT DL is working on with the Qataris. They're putting a hosted payload on a satellite called S-Hail, and that'll be S-band up, 2.4 up, and 10 gigahertz down. So if we get lucky and they're both up and working at the same time, maybe we can even cross-bridge them and cover the majority of the planet with 2 amateur radio satellites. Won't that be something?
Well, Drew, is there anything else that? Well, first let me jump back to Jerry. Jerry, was that most of the slides and the things that you wanted to show us?
I could show you if you want to cut to the pictures that we can see Fox 1C.
Well, somebody asked a question a minute ago about how they can help Fox 1C in the chat room, and we've got on the front page of amsat.org right now. I posted a note about the webcast tonight, and we've got some links on there. Fox 1C, we had to pay for the launch, and it was a substantial sum of money. 1A and 1B are via Alana, so those were subsidized by NASA. But for Fox 1C, we had to go out and put cash money down on it, and we're trying to recoup that now. If you go to amsat.org, there's some donate buttons right up front. We have on lots of the satellite Facebook groups, and on the AMSAT Facebook page, I posted a link to a fundraiser app. If you go there, you can donate, and for a $100 donation, we'll give you a nifty Fox Challenge coin. Jerry likes that side. I like the other side. Turn it around and show him, Jerry. The other side is a 1/4 scale model isometric view of Fox 1A, and that's a $100 donation, and we'll send you one of those. And we just put up tonight, we did this with Fox 1A, and we're going to do it again with Fox 1C. If you donate $1,000, we'll give you one of the solar panel covers. It's a Lexan cover that we used on Fox 1C to protect the solar panels while we're working on it and testing it. and there's 3 sets of them, 18 of them in total. So if you'd like to have one of those engraved with your call sign and the launch date and mounted on a plaque for your shack or your office, you can go over to amsat.org and help us out and help us get 1C launched. And of course, we'd always love to have you as a membership to support AMSAT too.
Well, the satellite aspect of ham radio is something very unique, and it's a great new aspect of ham radio. I got into it a few years ago, and not knowing what I was doing, and within about just a couple of contacts, I was a pro. I was making contacts on there, man. I was doing good. So we want to let people know it's pretty easy to get in here and make the contacts. And I know there's some easy birds. The AO51, that was very easy to work. Of course, it stopped. But you guys are going to have another easy bird up here pretty soon, aren't you, Drew?
Yeah, we sure are. There's going to be several new satellites real soon. One of them's already in orbit. EO80, which is an FM repeater satellite, uses the same bands as Fox will. It's 70 centimeters up and 2 meters down. It's in orbit and it's working on its scientific mission. And when they're done with that, they'll turn the repeater on for us. So we'll get maybe a little preview of what Fox will sound like. It's a little bit bigger of a satellite, but about the same output power. And there's a lot of satellites up there right now that you can work with real simple equipment, although they aren't FM. There is another FM satellite, not FM voice, but there's a PSAT, NO84, which was launched by the Naval Academy this year, and it has a rather unique transponder on it. It's a 10-meter PSK31 uplink, and then a UHF FM downlink. And the neat thing is because the downlink on PSK31 is FM, you don't have to tune the downlink for Doppler. The audio stays the same. You have to tune the receiver, but the audio in relation to the carrier stays the same. So, and it also has a digipeater on 145.825. So it's up there and working. You can hear it with a simple packet setup. You can try some PSK31 through it. We've got AO73, which is a FunCube1. It's a AMSAT UK satellite, AMSAT UK and NL, and it has a 2-meter transponder on it, 70 centimeters up, 2 meters down. Very easy to hear when it's on. And if you've got an 817 or an 857 or a 706 or anything that receives 2-meter sideband, you've got a good shot at hearing AO73.
Okay.
And FO29 is still up there and working. It's a real easy satellite to operate portable. There's a lot of guys now that have started working FO29 with an 817 and an Arrow. I've worked from Florida. I worked a station in Ireland, and he was using just an 817 and an Arrow, and really easy satellite to get on and hear and get started with.
Drew, I may have showed you this, or maybe I showed Jerry this. This is a 2.4 gig antenna I made. Did I show you this, or was it maybe Jerry?
You showed me.
I haven't seen that. It looks like a Helix for 2.4.
Yeah. And one of the satellites, did AO51 have that mode?
AO40 was S-band down, and AO51 had an S-band.
Yeah, this was AO51 when they flipped it on. They flipped it on very rarely, and I just had to see if I could make a contact on 2.4 gigs. And this cost less than $1 to build. There's a piece of printed circuit board there, a piece of PVC pipe, and it's got a piece of wire wrapped around it. And I think it was one of those little satellite down converters or receivers that did the conversion on, and it down converted it to, I forget what band, but actually it worked pretty good. But I think it was only on once or twice, and that's the only experience I had with that.
We ran it about once a month for a couple of days at a time. we ran it once during field day because we had some other FM satellites going, and it was probably the easiest satellite to make a contact on field day that year.
Oh yeah, yeah. All right. Well, yeah.
I worked AO 51. I took a cruise in 2008, and the ship was actually, I think it was registered in Bahamas or Bermuda. And so I got the license, the reciprocal license, everything, and I took my HT and Aero antenna, and I had talked to my guys in my local club up here in Azle, Texas. They had a club meeting on Saturday night that we were going to have a day at sea out there by Bermuda. So I made a contact with them. As a matter of fact, it was about, I'm thinking it was close to 1,800 miles, but we made a contact. Boy, that's hard to do, you know.
Well, let me go full screen.
Anyway,
with
they
you.
were
There we
back
go.
home. They were back home on their satellites and aero antennas wandering around out in the parking lot, and I was on the ship drawing quite a crowd, and we made a satellite contact there.
Well, that's cool.
BP9/N0JY.
That's cool out there now. You know, and I've been on a cruise ship a few times. It's pretty stable. You know, it doesn't move around like you think a ship does. So I imagine it's pretty easy to work the satellite. Hey, I've got something here I wanted to show, and people are starting to report that it's back up now, or at least they're seeing it. I've got something here I want to show. It's a picture, and maybe Drew can tell us about this picture.
Yeah, somebody's been on my QRZ page.
Yeah.
So with satellites, you can work DXCC with satellites much easier when we have a high orbit satellite. But like a lot of other VHF, UHF guys, we chase and collect grid squares. And that map is all the blue squares are grid squares that I have made a two-way confirmed contact with on satellite. And there's about 1,290 of them at this point.
So are you actually missing? Are you missing some of the western United States there?
I sure am. I've got 12 grids left in the continental U.S. to have all of the 488. On 6 meters, there's an award called the Fred Fish Memorial, and we don't have the equivalent. Well, we have the equivalent of that, but it's sponsored by a group in Memphis. Called the Gridmaster Award, and if you get all 488 of the continental U.S., and that's only been done, I think, three or four times now. So if you go to my QRZ page and look at the map, if you're in one of those grids out west, give me a call. I'd love to work with you.
Well, I think we had someone on here on the program a few weeks ago talking about. I think he went as a rover and gave someone's son the last grid he needed in the U.S. What was it, 288 or something like that?
Yeah, 488.
488.
That was John, K8YSE.
Right.
Son
right.
Doug, KD8CAO. So John and Doug have both completed it. And John went on a trip out through a bunch of the grids out west, the rarer ones, and confirmed those for Doug so Doug could get the award.
Well, and I've got a friend in Memphis, WA4NVM, Rick, and I believe he's worked off 488. I believe. I don't know if he's got any kind of certificate yet, but I heard him talking.
I think he was number 3.
Yeah, well, that's some accomplishment to do that. There's a lot of little boxes there.
There sure are.
Yeah. All right.
If you look at some of those, you'll notice that there's a lot of straight lines back and forth across the Atlantic and up and down the coast. Those are all courtesy of Yuri, UT-1FG Marine Mobile. He's a Ukrainian freighter captain, and he goes back and forth from Europe and South America. So when he's on, you may never hear that grid again. So
I was wondering about that. It looks like a little Y right there. And I was wondering why the darkness there. But this guy is in a ship and he operates satellite and he travels up and down the coast there and you're working.
Yeah. Quite exciting. You can see the trips back and forth across the Atlantic and back to different ports in Europe. So when Yuri's on, it's always a lot of excitement.
Yeah. Wow. Well, I haven't been operating any satellite stuff for a couple years. I've been thinking about getting my stuff back out and getting back on. The linear or the sideband birds are a little bit more difficult to work. I worked a few of them. They're not quite as easy, but you still got what SO50 up there that's fairly easy to work for newcomers.
Yeah, SO50s are our only FM repeater satellite at the moment, and it's a little difficult. You need a little bit of gain on receive to really work it well, and full duplex really helps on SO50. But at the same time, there's a lot of radios out there now that have 2 meter and 70 centimeter sideband. So if you get something like an Arrow or build one of the WA5VJB Cheeky Aggies, or an elk antenna, and you happen to have, one of the newer radios that have 70 centimeters or 2 meter sideband in it, you're not that far from being able to make contacts on the linear transponders. So it's worth cutting your teeth on SO50 and learning how to point and twist the antenna and do all that, and then it's not far of an upgrade to step up to the transponder satellites.
One of the questions that came in on the chat room is who built the CubeSat? Who actually, machined it and built it? And is it a lot of people? One person? How did that thing get built?
Everything in the Amsat Fox CubeSats was built by Amsat, by a volunteer somewhere. Some of the circuit boards were professionally assembled and soldered, but the prototypes were done by volunteers. And everything in there, all the metal, all the rails are custom designed, the frame, the circuit board, the solar cells are done by a volunteer at a professional satellite company. And everything in there is AMSAT designed and AMSAT built.
Yeah, and another thing I think we didn't hit on too much, maybe Jerry can answer this, the Fox 1C is going to have a camera in it. Now, none of the others had cameras, did they?
That's right. Fox 1A was supposed to have the Virginia Tech camera in it. The students there created that experiment. See, the purpose behind the design of the Fox satellites is that we have, if you can think of it as the lower half of it, is all of the radios and the computer and the power supply. The top 4 slots, we call them, we have 4 circuit boards, are for rent, and we've partnered with universities to fly different experiments in those. So Fox 1A has the first 2 experiment slots are filled with the Vanderbilt University radiation experiment. The third was to be filled with the Virginia Tech camera, but they weren't unable to complete it in time before we had the delivery. So we took that, which they have completed now, and I have it in the Fox 1C engineering model. So we will fly their camera, which is a JPEG camera taking 640 by 480 pixel pictures in Fox 1C and Fox 1D, and be able to take pictures of the Earth, mostly the Northern Hemisphere because of our license. It needs to be only images of Earth, and so the satellite camera will be only pointing at Earth basically over the Northern Hemisphere. If you can pull up the Fox Labs picture, I can point this out to you, how we've got that put together with the camera in there, if you want to do that now.
Yeah, let me pull it up in just a second. Now, one other thing with that camera, you got to have some type of stabilization on your satellite, I would guess, and to kind of cancel out some of this tumbling effect or whatever you might get. So is that something new that's going to be built in?
That's a good point. The Fox 1 series will use what's known as passive magnetic stabilization. In one corner of the satellite, near the center, is a pretty strong bar magnet, essentially, with the south pole pointing toward the top of the satellite as you see it on Earth, or what's known as the plus Z, and the north pole pointing toward the bottom, or minus the end of the satellite. And what that does is, through the magnetic field of the Earth, it's going to interact with that and essentially keep the satellite more or less pointed down towards the North Pole. If you consider this to be the plus ZN, for example, as it follows that magnetic field, when it's over the equator, it's going to be essentially parallel to the equator. And as it reaches the North Pole, it will point down. And then as it comes back around to the South Pole, the back end will be pointing toward it. So if you look at the picture that I guess you're showing.
No, I just did you want me to bring? I've got your Fox 1C camera up right now, or whatever.
Yeah, that's fine. Behind that's the Fox 1C actual engineering model sitting there in the Fox 1 lab. You can see that in the picture. You will see the sides are open. There are no solar panels on it, so you can see inside of it. The plug that runs into the left side is what we call the umbilical. We use that for charging the battery and also to talk to the internal housekeeping unit or computer in order to run diagnostics and such. There is an antenna. The transmit antenna comes kind of out the back in the picture there, which is hooked to some coax that I have it hooked to an external antenna at my house here so that other hams in the area can help me work with the telemetry and such. But right at the top, you have that little black square cutout, and that is the camera, where the camera's peeking right through. And I've zoomed in on it a little bit there. You can see the camera lens. And then through the actual top of the satellite, as you might have seen on the Fox 1A model, there's a cutout with an infrared filter over it pointing out to space through the solar panel. Okay. Now, did you say a minute ago that inside this little CubeSat, either 2 or 3 of those boards are basically given to colleges or someone for experiments? Yes. So that means, hey, that little 4-inch square thing there, you don't even have the use of the whole 4-inch square there. You've got about half that space to work with. That's true. Referring to the photograph there, what you see through that panel that's basically facing the camera, starting there at the batteries, those are the batteries that are wrapped in heaters that are the kind of copper colored there. That board and the 5 boards below it, 4 boards below it, yes, I can count. That is the avionics, the Fox avionics. The board immediately above it, you can actually see 3 of them before it disappears behind the metal there. Those are the spaces for rent. So the first 2 boards immediately above the batteries there are the Vanderbilt University experiment. The 3rd board up is the actual camera, and the 4th board is that top one that you see gold plated that the camera peeks through. In right now, I don't have the L-band experiment installed in the engineering model, so that is where that will go. Okay, so that really gives us a good look inside the CubeSat there. Another question: I know you have data transmission where you can give the satellite certain commands and do things, but there's no tight propulsion system here. You can't move it or position it in any way, can you? Not on this satellite, no. It is entirely stabilized by the bar magnet, and then also the way we have the solar panels designed, we'll have some photon imparted spin, so it should spin around the z-axis in a 1 to 3 RPM or so. We calculate spin, and that's dampened by some hysteresis rods that are located on that battery board, and that's what keeps it more or less so that the antennas are basically parallel to the Earth and always see the Earth because of that spin. They're just a couple of whip antennas, if you will. There's no directionality to them, no gain. Well, I see a question in here from N5UXT. Isn't that Angelo down in New Orleans or somewhere? N5UXT. Do you guys know him?
Yeah, I know Angelo. EM40.
Okay, I think that's him. He has a question. Once the batteries go out, will it run on solar? Well, hopefully you guys are designing it where it won't work like AO7. Actually, it's designed to work like AO7. Oh, it is? If the batteries short out, it's going to be unusable for 20 years? Hopefully not quite 20 years, because the orbit won't last that long. Oh, okay. The original design called for having some circuitry so that it could sense that the battery was shorted, and it would therefore remove the batteries from the circuit. Back in 2013, because at that time our launch was looming as early 2014, that portion was canceled due to some real estate changes. We had to make some changes to the design because of the additional inhibits that were required for this NRO launch. And that put a squeeze on the
real estate that was available for that circuitry. It was decided to remove those at that time. So this does not have that, what was once, it was actually highly touted at the beginning, is that they would have a feature that would be able to do that. But that was taken out because of time and not having a good place to be able to design it into those little 4-inch circuit boards. Did you have something that you wanted to add to that, Drew?
Yeah, that was the original intent, was to have it able to work without the solar cells. We do need to mention, however, zombie mode on it. Unlike AO51 and some other satellites, that if the IHU fails to work, the repeater doesn't work. The Fox satellites are designed that if the IHU fails, the repeater will continue to work. Battery failure is probably not going to be the downfall of the Fox satellites, because their orbits are anything that goes to orbit now has to be out of orbit 25 years after the end of its mission. That's orbital debris requirements. So the orbits that these satellites are going to will clean themselves out probably within the time that we would expect the batteries to last.
That's true. I can't tell you exactly for Fox 1A, but it's designed, engineered to last 5 years. The orbit will last substantially longer than that. Fox 1C, the orbit, it looks like, will be around a 7-year lifetime.
Okay, I think we may have a question. Let's see. We may have a question here, and Kathy, you want to try to read that to us?
Yeah, this is from Nick KE4MA, and his question is, what are the specifications of the orbit it will be in, km, kilometers?
For Fox 1A, I can't give you specifics because of that classified mission, but it's 480 kilometer perigee by 740 kilometer apogee and about 64-degree inclination. For Fox 1C, it's going to be in a sun-synchronous orbit, and I can't tell you any more about that because of a non-disclosure agreement.
It'll be similar. 1A will be similar to SO50, and 1C will be more like AO27.
All right. Any other questions? It looks like we lost Ted earlier tonight, so we're going to continue here without him for now. Let's see. Question. Please describe Fox 1A's AFC, making Doppler correction on the uplink a little different than current birds.
I can tell you what the AFC is, and Drew can talk about the operation. How's that?
Okay.
We added AFC to Fox 1 design so that it will, because the UHF uplink has more of a Doppler shift, it, in my testing, is capable of tracking a signal up to 10 kilohertz off frequency. As a matter of fact, accidentally, in some of this neighborhood testing I was telling you about, one of the guys that I test with had his HT program for 145.99 megahertz instead of 145.98. Excuse me, on the uplink, it was 435.19. And I never knew he was off frequency. Of course, there was nobody competing with him because AFC is going to look for the strongest signal, and that's what it's going to try to tune. But the fact is, it was expected to function within 6 kilohertz either way, and it seems to be meeting that expectation and a little bit beyond.
So, with Fox, the Fox satellites being 70 centimeters up and 2 meters down, they're backwards from what most people have used before on FM. All of the previous FM satellites, except for SO35, were the other way around, up on 2 meters and down on 70 centimeters. So on those satellites, you leave your transmitter fixed because the Doppler is only 3 kilohertz, plus or minus 3 kilohertz, and you tune to receive. When it starts to get fuzzy, you go to your next receive step if you're on an HT. We reversed those on the Fox satellite for a couple of different reasons. First of all, the UHF uplink gets us away from all of the non-amateur traffic in the amateur band, especially south of here. There's a lot of taxis and fishermen and things like that, long distance telephones that use a 2-meter band. They shouldn't be there, but they are, and they can cause interference. By flipping that, we also picked up a stronger downlink. You have less path loss coming down on 2 meters versus 70 centimeters. So there were some other reasons there too. But what that's done is it means you have to tune the uplink now. The downlink will stay fixed. You won't have to tune the downlink at all. But without the AFC, you would have to tune the uplink. When the satellite's coming at you, you start low, because as it's moving towards you, it's compressing the wave, so you start low. And then you would have to tune through at least 3 steps. When it gets overhead, you're in the middle, and as it's going away, you tune high. If you didn't work SO35, that seems counterintuitive. Hopefully the AFC will ameliorate some of that, so you won't have to do the Doppler tuning. But if it doesn't, everybody should be working full duplex on the FM satellites. When you start to get fuzzy into the satellite, that's when you make your step, or you can do it on timing. If you make a notation, okay, at this point the satellite's going to be close to overhead and it's time to step the frequency. So hopefully the AFC will work and we don't have to worry about that. But if not, it's just going to be a little bit of a rearrangement and a little bit different way of thinking if you work the other FM satellite. But all the benefits should be positive.
I want to thank both of you, Drew and Jerry, for being on the show tonight. It was very interesting. Hopefully we got the message out about Amsat and what they're doing, and particularly about the new satellites here. And what we'll do, we'll get you back on here one day on a future webcast. So were there any other questions, Kathy, that you saw? Okay, I think we've hit all the questions that we had. Thank you again, Jerry and Drew.
My
appreciate
pleasure.
it.
Thank you, Tom.
Thank you very much.
Tom.
Thank you. 73 to you guys. So I think what we're going to do, we're going to go ahead and close this down tonight. We were going to show a couple people's shacks. Actually, the shack behind me is my radio shack. Of course, I'm blocking most of it there. I'll kind of move over and let you see part of it there. Anyway, let's see. I had a couple others here that were sent to me. Let me put those on real quick. This is N9EE. That's the shack of N9EE. And he sent that in today for us to use on the webcast. And also, this is from Larry. This is from Larry, WD0AKX. Larry's usually watching. He may even be on here tonight. So this is Larry's ham station right here that you're seeing in the background. If you guys have your a picture of your station and you want to send it to us, we'll try to put that picture on our webcast. Okay, well, it's been kind of a tough night. I know there were a lot of storms going through the area tonight. We had 14 severe storms and 70-mile-an-hour winds just earlier. In fact, I've got the weather radar map here. Let me throw it up there. There you go. You can see what we went through. Now, I'm not a weatherman, but you can see what we went through in the last couple hours right here. And I don't know. I'm looking for Memphis. Where's Memphis? Oh, it's right there. Oh, that's the wrong way. Oh yeah. I got to get used to the weather map here. Memphis is right here. But you can see all the severe stuff here that just went through here in the last couple hours. I don't know if that's affecting the internet in some way. Maybe it is, maybe it's not. I don't know. So we'll look into this, and we'll see what we can do. So I'm going to go ahead and say 73 to everyone out there. Thank you for tuning in tonight and watching. Really appreciate those that come in on Tuesday night and watch and help us spread the word about the webcast. We got a hangout going. Kathy, you want to send the link out again? All right, I'm going to try to get on Hangout, and anybody who wants to get on Hangout and join us, please do. We'll put that up on the webcast here. So the webcast, we're going to keep it up for a while. And if you'd like to be on the webcast, just click that link and join us with Hangout there. So 73 to everybody, and I'm going to go over and log into Hangout, and we'll be right back in just a moment. On here we go.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.
Okay, we're back, and let's see, we got anybody in Hangout tonight?